Exciting to see so many of you joining. 24, that's quite a bit, especially for such a niche topic. So my name is Simon Aronsson, and I'm a developer advocate with the company K6. And over the last couple of years, I've spent a lot of time on test automation practices and building robust engineering cultures where testing is not considered an afterthought, but a natural reoccurring activity in the software development workflow. I'm a developer myself, but I've been testing quite a bit for the last couple of years. And today we're going to talk about load testing or performance testing in general and load testing in particular. And we'll have a look at how to use open source tools to build, execute, automate, and visualize performance tests, mainly load tests. And before we start, I'd just like to speak a little bit about the topic of load testing and what it is. Because I assume not everyone joining today have actually practiced load testing before. And load testing is a practice that is all about generating load on a system that resembles production load from actual users. And we do this by executing load tests using different load profiles or load models to simulate real-world scenarios that we want to build confidence around. For instance, what would happen if our product or service suddenly hit the front page of Hacker News, or started to trend in a popular subreddit? Or what if we want to prepare for Black Friday, for instance? We might have an average of, say, 100 users at any given time, but during Black Friday, that we might see that number increase tenfold without any prior warning. So by using load testing, we'll be able to assess what would happen if that would actually be the case. And it can also be used to verify other things like whether or not our automated scaling works, or to analyze the effects of gracefully failing nodes in our cluster or in a distributed system. So what would, for instance, happen if one of our web frontends were to go down during peak traffic? Would we still be able to serve all our users using our other nodes, or would we suddenly start to see failures where users would get bounced due to our service trying to recover? And in this talk, we will mainly be doing a demo. And when we're done with this demo, then we want to have integrated a load test into a CI workflow, where we either can trigger the CI by doing commits on the master branch, or by triggering it manually from a web UI. We also want the CI to tell us if we suddenly stop fulfilling our service level objective, or if we fail a performance threshold that we've defined. And we also want to be able to monitor the performance visually without having to run it ourselves. So, for instance, if someone were to push a commit to master, we would want our performance test to be run and our results to be visualized in our visualization tool. And all of this can actually be performed with open source tools. We don't actually have to pay anything to do this. So we'll be using an open source stack mainly, with one exception for this demo. We'll be using GitHub Actions, which is the only tool we'll use that's not open source, but it's available for free. So we'll have to make do with that. But you could just as well use Jenkins or any other CI you prefer. And we'll use GitHub Actions to automate the execution of our load test.
Hello.
We'll then use K6 to generate the load, as well as making sure we're staying within our acceptable threshold or SLO. And the metrics we generate from the load test will be sent to InfluxDB, which is a time series database, to finally be presented in Grafana, which is a visualization tool. To make this as easy as possible, we'll be using Docker to run most of our tools, so we don't have to install anything locally on our computers. And sorry, I got a notification. I just have to turn it off. There we go. All right, so when we build load tests, a common approach for doing that is to use some kind of browser recorder or proxy to capture the traffic that occurs within your system or when someone uses your system. And while this is a great way to get up and running quickly and with zero to little coding involved, we usually recommend users to write their load tests themselves using JavaScript. This has, in our experience, proven to be a lot more maintainable over time, especially when we integrate it with our CI. So let me just switch my screen sharing. All right, you should all be able to see my editor now. And I'll turn off my webcam as well to make it a little less in the way. So well, let's start off by creating a JavaScript file where we will place our actual test. While this is actually programming, the syntax for writing load tests in K6 is actually quite simple or quite scaled down. So with the help of the documentation, you should be able to write a decent performance test even without prior programming knowledge. So we'll start off by defining our VU function. And this function will be executed once for every iteration that our VU makes. A VU, when in load testing terms, is a virtual user. That is a simulated user that performs something that a normal user would. And this function that we define, it will be executed synchronously from top to bottom, one statement at a time. And for the test to actually do something, we'll now add a request using the HTTP client that is built into K6. We'll then save the response of that request and do a check to make sure that our assumption about the outcome are correct. So we'll start by importing the HTTP client, as well as importing the check. We'll then do our HTTP call. In this case, we'll do it against a test API that is available on the K6 website. And we'll then define our check based on the result. So for every request that we make, we want to assert that the HTTP response status code is 200. So we write a label, HTTP response status code is 200. And we then create an expression that evaluates whether that is the case. So in this case, we'll go ahead and check that the status of the result object is 200. Let's run this just to make sure it works so far. All right, so we can see here in the terminal that it actually went well. We did one HTTP request, and we also get a lot of statistics or data about how this went. So we can, for instance, see that the request duration for this request was 108.45 milliseconds, which I think is acceptable for a demo API. We can also see that 100% of our checks actually passed. So 100% of our one call had the HTTP status code 200. Awesome. So far it works. Now we need to make this fail on errors as well. So let's set up a threshold saying that we expect all requests to finish without errors. And let's also add a threshold for the request duration, or for the 95th percentile of the request duration. We'll express this in case 6 as a threshold. This could be any of the performance SLOs that you have defined for your team or for the service that you're maintaining or operating. So we'll start by importing a metric object, which is also built into case 6. And in this case, we want to do a rate. We'll then create a rate object out of that, and let's name it failed requests. We'll then also export a variable called options, where we can set some options for the test run or for case 6 to take in during runtime. And in this case, we'll add a threshold, or we'll add 2 thresholds. One called failed requests, where we express a condition for this to be considered passed. In this case, we want the rate to be less to or equal to 0, less than or equal to 0. And we also want to set up a threshold for the request duration. And we'll say that the 95th percentile should have a duration less than 500 milliseconds. We'll then also make sure that if the status code is not 200, then we'll add 1 to our failure counter. Otherwise, we'll just add a 0. So failures add result.status is not equal to 200. And if we now go ahead and run this again, we'll see that another metric has appeared. We now have failed requests as one of our metrics in the summary. And we can see that 0% of our requests were actually failed. So that's great. We're able to do 1 request against our test API without it failing. But that's not really that helpful, right? Because 1 request, hopefully all systems can handle that. But we need to bump up the volume a bit and add some more virtual users and a longer duration than 1 iteration. So we'll go ahead and do that. We'll add to the options object that the VU count, or the virtual user count, should be 10 instead. And that the duration for our test should be 10 seconds. If we now run this again, we should have 10 virtual users trying to do as many iterations of our test function as possible during 10 seconds. Hopefully we'll land around at least 100, but we'll see what we get out of this. So with that, let's run it again. K6 run test.js. That was not 10 seconds. Let's see what happened here. My bad, options. There we go. It will now run for 10 seconds with 10 VUs. And as you can see, it was a whole lot more than 100 iterations that I thought. It was actually 856 during this 10 seconds. And now our our metrics that we get in the summary make a whole lot more sense, since they don't all just show the same. We can, for instance, see that the average HTTP request duration was 111 milliseconds, while the lowest was 103, the median was 109, and maximum was 222. We can also see that for the 95th percentile, the duration was 120 ms, which is more than acceptable in my book, at least for a demo service. We can also see that all the checks passed and that we had no failed requests, and that doing this test consumed 10 megabytes of data, or rather we received 10 megabytes of data while we sent out 115 kilobytes. All good. Now that we have that up and running, we should probably go ahead and add that to our CI as well. And just to make things a little simpler, or for the sake of time mainly, I've gone ahead and already created a repository that we will use for this. So just let me switch my screen again. So we have a repository on GitHub called Passion for Testing. And what we want to do here is push our code to this repository and then have it run whenever it detects any change to the master branch. And when we do that, we'll see something happening in the Actions tab. Let's see. There we go. So let's take our change, test.js change, commit that, and push it to GitHub. All right, if we now refresh our window, we'll see that the changes have appeared in our repository. We have the test.js file here. But we'll also see that since we haven't set up any action, nothing will really run for now. So we'll go back to the code editor and add that script as well. So we'll create a new folder called .github. And in that, we'll create a folder called workflows and a file called main.yml or YAML. So GitHub Actions is quite simple to use. It uses almost the same format as most other CI vendors. So if you've used Jenkins before with Jenkins files, or if you've used Bitbucket pipelines or Azure DevOps or anything like that, you should probably feel quite at home with GitHub Actions as well. So we'll start off by giving our workflow a name. Let's call it main, or rather call it load testing workflow. We'll define what we want this workflow to trigger on. We want it to trigger on pushes, and we also want to be able to manually dispatch a test run. So we'll be able to trigger it from the UI using a button, basically. And the jobs we want to be included in this workflow will just have a simple one-step job called test. And the label for that will be run load test. We will run our test on the latest version of Ubuntu. We want the steps to be first checking out the code. We'll need that to be able to run our test. And then we run it using a K6 action available on GitHub Actions. So we don't have to actually set that up ourselves. And we want the file name for our test to be test.js, which corresponds to what we've set up here. And that should be it. So if we now go ahead and push again, we should be able to see that the action has actually been executed in the GitHub UI. Okay, we can now see that our new file is present as well. And if we go to actions and enable actions, then we can see that our workflow is actually present here. So let's go ahead and run it here. So what happens now? Well, we're going to run our load test on a cloud test runner provided by GitHub. So we don't actually have to care about setting this up ourselves or having a dedicated testing machine. So whenever we want to run a test, we can just go to the Actions tab and click Run Workflow. And it will spin up the machines needed and execute the test. And we can also follow the logs. So it starts by checking out our data, and then it runs the load test, just as it did locally. And we can browse through the end of test summary, just as we did in the terminal. Awesome, great. So now whenever we would push a change to our repository, these tests would be executed. So we can build that into our regular quality assurance pipeline to make sure that we don't have any performance regressions. And in case we do, the workflow will actually fail whenever we pass any of our thresholds that we defined. So for instance, if we would have errors, then the workflow would fail and would get notified immediately that we have something we need to take care of. The same goes if there's suddenly a request duration change that makes all operations against the server slower than they usually are. So this is a great way to be able to set up performance goals and then forget about them and be reminded whenever there is an issue that we need to take care of. I'll just go ahead and switch the screen sharing again. All right, so with that up, we now need to set up our Grafana instance as well as InfluxDB, which we'll use to store the performance metrics that we generate with our load test. And in the K6 repository, there is actually already a Docker Compose file available. So the only thing we'll have to do to be able to do this is to run Docker Compose up -d InfluxDB Grafana. This, of course, requires you to already have Docker installed on your computer, but at least on Windows and on Mac OS, it's fairly easy to install Docker, and you can usually do it without that much hassle. So if you want to try this after the talk, make sure you have Docker installed before you start. All right, so we can now see that we have a Grafana container as well as the InfluxDB container. We now need to make the InfluxDB container available over the public internet to be able to send metrics to it from our load test. So let's expose that using ngrok. In a real scenario or in a real production environment, we would probably do this by configuring our firewall to port forward to our server in this particular case. But to keep the scope as small as possible for the demo, we'll just use ngrok, which does all of this for us. So ngrok http 8086, which is the port of InfluxDB. Apparently I had that open somewhere else. 1 second. Let's try again. All right, we can now see that ngrok has created a URL for us that is publicly accessible and that will lead to our InfluxDB container. So we'll take this URL and we'll add this to our workflow using the flags property. So here we can tell K6, or we can use whatever flags we would use in the CLI, just the same. So we'll tell it that we want to configure an output, and that output should be InfluxDB, which is available on this URL. And once we push this, the load test should start. And we should also be able to go into Grafana and see that we get performance data. So let's push this. And then switch back to the GitHub window. As you can see, our latest commit actually triggered a test run, and it has the same message as we used in our commit message. And if we open it up, we'll be able to see the logs just as before. We can now see that it actually is configured to use ngrok as its output in the summary as well. And if we now switch to, or if we now go to Grafana, which we have available at our local host, we'll be able to open a pre-configured dashboard that actually shows us the metrics generated from our load test. I'll go ahead and up the duration of our test to 1 minute, just so we'll be able to see some more data in real time. All right, our test is running, and we should now be able to see data coming in. Let's turn down the range a bit to 5 minutes or so. And here we go. In about 30 minutes, we've created our first load test script. We've set up our CI to use that and execute it automatically. And we've also been able to create visualization that will show us what is going on in a more easily digestible or understandable form. And if we wanted to elaborate on this, or rather expand on it, then we could, for instance, create a load test that simulates a whole user journey. Say, for instance, that you work for an e-retailer and you want to test the web shop. Then you could, for instance, log in, search for something from the product catalog, add that to your shopping cart, and check out, and make sure that that is done at scale, maybe 100 or 1,000 virtual users concurrently, and do that for an hour and see what happens. And by doing that, we'll be able to assess what would happen, for instance, if we will get a traffic surge during Black Friday. let's see if there was anything else I wanted to mention. Yeah, one last thing. If you're thinking of running this in production, which I strongly encourage, testing in production or the actual environment where your users will be in is really great. It gives you a much better picture of what the actual outcome will be. I mean, regardless of how much effort we put into creating production-like staging environments, it will still not be the real deal. And as such, the results will not necessarily be representative. But just as you wouldn't learn math from scratch by trying to solve the traveling salesman problem, we should learn to walk before we try to run. So you as testers, of course, already know this, but we should always start by testing in a non-production environment. Make sure we get what is happening and that nothing breaks in a way that we've not anticipated. And once we feel confident with that, we may then move into production, repeating the exercise with fairly low risk as compared to going directly to production. And last, applications create data. So if you test in production, this data should be carefully segmented so that it never crosses the boundary into real user land. For instance, if you have a scoreboard showing the most active users of your app, then you probably don't want the #1 spot to be your test user. So you need to make sure that you plan ahead and that you make the blast radius as small as possible to avoid degrading the experience of your actual users. And that concludes my talk. So I'll let Jonas on again, and we'll probably see if there are any questions.
Yeah, thanks, Simon. It was a great talk. Yeah, so are there any questions? You could raise your hand, so, since there are so many. So can I give you the word?
Yeah, Mike, I have a question.
Sure, hi.
Hi. What about the performance counters from the target servers? Can you integrate that in Grafana too?
Yeah, for sure. You could, for instance, set up distributed tracing or observability or whatever you want, and have that imported into Grafana as well. If that's something you're interested in, I'd recommend you to actually a little bit of hidden ad here, but to attend a webinar by New Relic next week, where we will go into detail on how to integrate distributed tracing and observability into a load test so you can correlate these data. But it's certainly possible. You can do it with Grafana, you can do it with Datadog or New Relic or whatever APM software you use, for sure.
Okay, yeah. Because you want if you have a slow response time, you want to have the dig in the region for the lowest response time.
For sure, that is really helpful, right? If you, for instance, were to hit the main endpoint that you're testing, and suddenly you get a HTTP request duration of, say, 2 seconds, then you'd probably want to know what action is causing that delay. And especially if you're in a distributed environment where services communicate with each other over HTTP behind some kind of API gateway, then you would probably want to correlate that with whatever handover time you have between those services behind the API gateway. So for sure, that makes total sense.
Mm-hmm.
And it is possible, yes, to answer the question.
Yeah, it's a matter of if you have the rights to open ports and where the environment is and so on, of course.
Yeah, for sure. And it also usually, depending on if you're on a cloud provider like AWS, they usually have it built in. But if you host yourself, then you probably would need to instrument your application as well to make sure that it actually sends out these metrics as things occur in the application.
Yeah, of course.
Hi, Simon. I have a question related to the virtual users. If we want to kind of, if the users required valid logins to be able to access the environment, do we need to set up all virtual users with valid accounts beforehand? I mean, if I would like to scale up amount of users.
That would certainly be one way to do it, to create test user that covers all the virtual users that you will be running. But another way to do that would be to actually build in, say, the sign up flow, for instance, into your load test, and have the users actually create an account for themselves, run the load test, and using that account. But for sure, if you have to log in to test, then you either need a API token, or you need to do some kind of data, you need to do some kind of correlation of data to make sure that you get that token into your request. Because while you can record your user journey, that would create a static login token, right? So once that token expires, then the load test will fail. So you'll have to do that in some dynamic way, for sure. And with the test recorder that we provide for Chrome, that is to some extent built in, so it does the correlation automatically for you. So that's absolutely possible, or a way to solve it. But either you'd need to create enough user accounts to cover the virtual users, or you would need to have the users sign up themselves.
Okay, thank you.
Are there any more questions? Or? Yeah.
Hello, Per here. I'm just curious. I didn't quite follow what's the setup with the server, the controller driving the tests, and the possible load test clients that are serving the load towards the server. I assume, did you run everything on the same machine here, or did you use
Yeah, for sure. With K6, you usually don't have to create a distributed, or you don't have to create distributed load generators. But you'd rather be able to run the whole load test on one machine. We've been able to simulate up to 30,000-40,000 users on one machine. So for most use cases, it should be enough with one machine. So no additional server should be needed. But we also did this in 2 steps. The first step, we run it locally on my machine, and then we run it on a smaller virtual server or container provided by GitHub. And the exact specifications of that machine, I'm not really sure of, but I know of companies or organizations that have run at least 1,000 virtual users on those as well.
So the Ubuntu step you did was served by GitHub, that VM or whatever you should call it.
Exactly. Okay. So they take care of the provisioning of that, and we just get to run our test.
And if you want to get different data from different parts of the world, so like you want to simulate some users from South America and some from Australia and so on, to see if there is some sort of behavioral difference.
That's certainly possible. We have a project on GitHub called K6 Operator that would use Kubernetes to do this, where you can force parts of the test to run on different nodes, and you can place those nodes wherever you want in the world. But that's quite bothersome. So in that case, if your use case requires geographic distribution, then I would actually recommend our managed cloud service, where we do that for you. So you just specify the regions, and it will populate servers equal to the distribution you've set up in these regions.
Cool.
Anyone else? I think Mats Jonsson raised his hand.
Do you have any question, Mats?
He solved that by disconnecting instead. So I think it's it's fine. All right.
Are there any more questions? And I have been recording the session as well, so I will make that available after the meetup and send out the link to it.
And I'll keep the repository, the demo repository on GitHub. So if you go to my GitHub account, github.com/simskij, then you can see the files we pushed there, and you can even fork it and try it yourself. And you have my Twitter as well if you have any further questions, or if you want to get in touch and talk more about performance testing or chaos engineering or any other topic related to reliability.
So are there no more questions, or otherwise I think, oh, it doesn't seem like it. And then I think we give Simon a virtual applause and thank him for today.
Thank you so much for having me. It was a pleasure.
Yeah, it was
Yeah, thank you very much.
Thank you.
Thank you so much.
Thank you.
Yeah, thank you.
Thank you.
Thank you very much.